Okay, so what we want to look at is the difference between slope and elasticity. And I've already got the slope up here. It's defined as the change in y, delta y, divided by the change in x, delta x. So we could go to a price of $8 where the quantity is 100 and a price of $7 where the quantity demanded is 200. So 8 minus 7 is 1. 100 minus 200 is 100. And the overall sign of this is negative because this line has negative slope. Because it is a straight line, slope is constant. If we go to any other point along here, we would find the same slope. I've done that. I've gone down to a price of $2, and the change between $2 and $1 corresponds to a change in the quantity demanded from 700 to 800. Once again, 2 minus 1 is 1. 700 minus 800 is minus 100. Again, overall sign negative here. As you can see, both times the slope is the same. It's 1, negative 1 over 100. So now, just to see the difference, the price elasticity of demand is the percentage change in quantity demanded divided by the percentage change in the price. If we go to the specific formula used when we have two different points along our demand curve, we use the midpoint formula, and we can either go in either direction. We can start at Q2 or go to Q1, or start at Q1 and go to Q2. Because we are doing the midpoint, it takes out the fact that we would get a different value depending on which point we started at. So that's the nice thing. The value is going to be the same regardless of where we start. So we're going to just try this here. I wanted to show you the overall formula. You take the difference between the quantities demanded at the 2 points, divide that by their sum divided by 2. And we're just finding the average or the midpoint between Q1 and Q2 instead of dividing by Q1 or Q2 like you would if you were doing a percent change. Q1 minus Q2 divided by Q2 or something like that. That would change because if we reversed it, then it would be Q2 minus Q1 divided by Q1, and you'd get a different value. This way we get the same value every time. Now the overall sign of this is going to be negative because the demand curve is negative. We don't want that to interfere, so we're actually going to ignore the sign or take the absolute value of this quantity. But let me just get this formula out of the way, and I will put some numbers in and show you exactly how we calculate that at two different places along the curve. So now here I've plugged in the numbers, and we're looking at the price elasticity of demand. How responsive is the quantity demanded to a price change up in the upper part of our demand curve, where what we should find is that it's going to be elastic. So I've just plugged in the numbers. Remember, it's the change in quantity demanded up here. So at 8, the quantity demanded was 100, minus at 7, the quantity demanded was 200. I divide that difference by their sum divided by 2, finding their midpoint. So that's going to be, again, remember we ignore the sign, so the fact that it becomes a negative 100, we just drop the negative sign. So the difference between the two is 100. In the bottom we get 150. 100 divided by 150. In the denominator, it is the percentage change in the price. So we went from $8 to 7. 8 minus 7 is 1. And then we find the midpoint, 8 plus 7 divided by 2, which is 7.5. So now I've got this fraction 100 divided by 150 all over 1 divided by 7.5. I can just invert and multiply, so I can say, okay, 100 divided by 150 times 7.5 divided by 1, which is going to equal 750 divided by 150, or 5. Since the number 5 is greater than 1, yes indeed, we do have a price elasticity of demand value that is elastic, as we would expect to find in the upper range. Now we're going to do this again, looking at the price elasticity of demand down in the lower portion of our demand curve. Okay, now I've just plugged in the numbers down here between a price of $2 and $1, quantity demanded of 700 and 800. So 700 minus 800 gives us a difference of 100. Again, we dropped the negative sign. That number has to be divided by the midpoint of those two quantities. So we add them together and divide by 2. That's 750. And then down here we have the price of $2 minus 1, which is 1. And 2 plus 1 is 3, divided by 2 is 1.5. Now, instead of dividing this fraction by that fraction, we can just invert it, turn it over, and multiply. 1.5 times 100 is a 150. 750 times 1 is 750. If you divide 150 by 750, the answer is 0.2. Since 0.2 is less than 1, we say that this is an inelastic value for the price elasticity of demand. So even though we saw a moment ago that the slope was constant, it was the same between these two prices and these two prices, now we see that we get two different values for the price elasticity of demand. Up here the value was greater than 1 or elastic. Down here it's less than 1 or inelastic. And then of course somewhere in here the change between the two is exactly equal to 1, and that is what we call unit elastic. Okay, so this is the wrap up for our application of the midpoint formula. I didn't do it, but you can test it for yourself. Between $4 and $5 is where we're going to have price elasticity of demand equal to 1. So that's where we find the price elasticity of demand is unit elastic. Everywhere below that is the inelastic range. The value is going to be less than 1, and everything above that, all these prices, are going to see a price elasticity of demand greater than 1, so we say it's the elastic range. In the next video, we're going to look and use that elasticity to look at its effect or impact on total revenue. All right, thanks. Come back to see the next one.